Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over part 3, problems 11 to 15 of the ACT math practice questions. You can gain access to this document on www.actstudent.org. All right, let's take a look at question number 11. It reads, students studying motion observed a cart rolling at a constant rate along a straight line. The table below gives the distance d in feet the car was from a reference point at 1 second intervals from t equals 0 seconds to t equals 5 seconds. So we have the table here. Which of the following equations represents this relationship between d and t? Alright, there are two methods that I'm going to use to show you how to do this problem. The first method is a method that you can use if you've studied physics, okay? Method 1, we're going to be using a physics equation that relates distance, rate, and time, okay? So distance equals rate times time. This is known as the dirt equation, okay? Distance is equal to rate times time. Okay, so if you want to use this equation, what you have to do is you have to recall that the distance covered is equal to rate times time plus the initial distance. Okay, now all we need to generate the equation for this situation is we need to find out what the rate is and what the initial distance is. Alright, so the rate can be thought of as the slope, alright, the rise over the run. So the rate is basically change in d divided by change in time, all right, or y2 minus y1 divided by x2 minus x1. In this case, d are your y's. So to compute the rate, we just ask ourselves, for every unit change in time, how much did the distance grow? Okay, so from 0 to 1, we have a 1 second increase in time. From 14 to 20, how much increase is that? That is plus 6. Okay, and then if you keep on going for another 1 second increase, you have another plus 6 increase in distance. So the rate in this case is simply 6 change in distance over change in time for that interval, 1, 6. All right, now the initial distance is where you started from at t equals 0, or when you started to calculate. Okay, so for this problem, we're going from t equals 0 seconds to 5. So our initial distance is what the distance was on the table when t is equal to 0. So when t was 0, what's the distance? 14. Okay, so d sub 0 is 14. Now we'll put these pieces of information together in this distance equal rate times time plus initial distance equation. We have d equals the rate, which is 6, times time plus the initial distance of 14. We can clearly see that our answer is option letter C. All right. Now let me show you another way of doing this. Assuming you do not know about the distance equals rate times time equation, you can just use a simple method of plug and chug. Okay. Method 2. I'm going to call this plug and chug method. What on earth is that? Well, plug and chug just simply involves substituting the values of t and d into each equation and see which one results in a true statement. Okay, so we're basically working backwards. We're testing the answers using the question to see which one works. Okay. Now, what you want to do is you want to pick a test point, okay, a t and a d value that you want to test these equations with to see which generates a true statement. You might want to avoid picking the first coordinate pair because sometimes you have a situation where the first pair satisfies multiple equations and you have to advance to the next combination. In this problem, just to play it safe, I will select the third pair, okay? The third pair, we have t is 2 and d is 26. So we're going to pick the ordered pair 2, 26. And then we're going to do a test, okay? we're going to see which satisfies this statement. Statement d of 2 equals 26. What does this statement mean? It means that which of this table will yield 26 as a distance when I plug in 2 as a time? Okay, so let's go ahead and test them out. Let's start with option A. Option A, distance d, that equation is t plus 14, right? So d of 2 simply means you take t out and replace it with 2. Okay, 2 plus 14, that's 16. Is 16 equal to 26? The answer is no. 16 is not equal to 26. That's a fail right there. So what does that tell us? Option A is not the correct answer. What do? Proceed to the next one, option B. What does d of 2 using that second function yield? So d of 2 for option B is 6 times t, which is 2 plus 8. 6 times 2 is 12 plus 8. 12 plus 8 is 20. That is not equal to 26. Remember, we're looking for what is equal to 26. So that's another fail. Option B is not correct. Option C we already determined is the correct answer, so hopefully it works here. Option C, what is d of 2? d of 2 is 6 times 2 plus 14. The goal is to get 26. 6 plus 2 is 12. 12 plus 14 is 26. That is equal to 26. Perfect. This is your correct answer. Now, this is the question. If you are using this method and you arrive at an equation that satisfies an ordered pair that you selected, does that mean you should stop there? The answer is no. You must test every equation because sometimes you have multiple equations that satisfy a selected pair, so you have to use more combinations to see which one satisfies it. Okay, the true equation should satisfy all of the ordered pairs. Okay, so the fact that C works doesn't mean you are going to stop. You have to exhaust all the options provided. So we're going to move on to D. Test it out. D of 2, what results there? We have 14 times 2 plus 6. 14 times 2 is 28, plus 6 is 34. 34 clearly is not equal to 26. That is another fail. Last option is option E. What is D of 34? Does that yield 26? So D of, D of 2, using 34t as the function, D of 2 is equal to 34 times 2. 34 times 2 is 68, which clearly is not equal to 26. That is a fail. We can clearly see that our answer is option letter C. Alright, let's take a look at problem 12. It reads, the length of a rectangle with area of 54 square centimeters is 9 centimeters. What is the perimeter of the rectangle in centimeters? Okay, one tip I want to give you concerning working with geometry problems of this nature is that if a problem involves a geometric shape or some figure and the problem is presented in text format like this, you always want to create a visual, a sketch of the situation to aid your comprehension. Okay, in this problem we're dealing with a rectangle, so what is the smart first move? To draw a rectangle. Okay, so draw your rectangle and then use the information provided to populate the dimensions. Alright, the problem reads, the length of a rectangle with area 54 square centimeters is 9 centimeters. What is the perimeter of the rectangle in centimeters? So let's go ahead and populate the dimensions of this rectangle using this information. So the area as this enclosed region right here is 54 square centimeter. The length is 9 centimeters. So this is 9 over here, and this is also 9. What's the width? It's not provided, so the width is unknown. Okay, so in order to solve this problem, we're going to be writing down some basic geometry formulas concerning the area and perimeter of a rectangle. Why are we focusing on those formulas? Because it talks about area here and perimeter also. This is ultimately what we're looking for, the perimeter. So let's write down some formulas real quick. Alright, so the first formula we're going to write down is the area formula. So the area of a rectangle is simply given by the length multiplied by the width. Okay? How about the perimeter of a rectangle? The perimeter of a rectangle is the distance around it. So the perimeter of a rectangle can be computed by adding the two lengths, which are equal, so you just double the lengths, and the two widths, which are equal, so you double your width. Alright, so those are the formulas we're going to be using. Now, let's take a look at our strategy. How do we want to approach this problem? First thing we're going to do, we are going to use this area formula. It's provided for a reason. For the perimeter, we need to know the length and the width. We only know what the length is. So the area is the key towards determining the width. And as soon as we have the width and the length, we can compute the perimeter. Okay? So step number one is we're going to use the area formula to determine the width. All right? To determine W. After doing that, we're good to go. We're then going to use the perimeter formula to find the perimeter. Okay? To find the perimeter. So this is the strategy that we're going to be using. Okay, so let's start with the first part. Part number one. Let's find the width, W. Okay, so formula for area, let's just write it again. Area of a rectangle is length times width. We're told that the area is 54 square centimeters, the length is 9, and the width, we do not know what it is, W. Let's leave it just like that. Okay? Alright, let's solve this resulting algebraic equation for W. So 54 is equal to 9W, and to solve this, you simply divide both sides by 9. And you have a width of what? The width is 6. Okay? Alright, we're done with step 1. How do we proceed? Step 2 is to use the width and the length in the perimeter formula. So number 2, we want to find the perimeter. We have all the information that we need to calculate this. So to find the perimeter, we know that P is equal to 2L plus 2W. So if we carry out a substitution, our L is 9, the problem gave that to us, and then 2 times W, which we found is 6, and that gives us 18 plus 12. Our perimeter is equal to 30 centimeters. Answer is option letter K. Alright, let's take a look at problem 13. It reads, in the figure below, C is the intersection of AD, segment AD, and segment BE. What is the measure of angle BAC? So we're looking for the measure of this angle right here. Now some things to remember concerning elementary geometry are as follows. Vertical angles are congruent, okay? And you also have to remember that the sum of angles in a triangle add up to 180, or they're supplementary. That means exactly the same thing, okay? Now let's see what we can do here. We're looking for this angle. So if I can find this angle right here, then I can use the triangle angle sum theorem to figure out what this angle is. All right? So let's see, can we determine the measure of angle BCA? Now, what do we know about angle DCE and angle BTA? BCA. They are vertical angles. And what do we know about vertical angles? They are congruent. Okay, so let's write down an equation real quick. Measure of angle BCA is equal to measure of angle BCE, and the reason is because they are vertical angles. So vertical angles they're basically congruent. All right. Now, what do we know about measure of angle DCE? Since measure of angle DCE is equal to 45 degrees, that follows that. Then measure of BCA is what? It's 45 also, since they're congruent angles, 45 degrees. All right, so let's see how much progress have we made. We've been able to determine that this angle right here, BCA, is 45 degrees. So do we have enough information to figure out BAC, measure of angle BAC? Certainly we do, because we know they all add up to 180, right? So we know that the measure of angle BAC plus the measure of angle BCA plus the measure of angle ACB is equal to 180 degrees. Wait a minute, I think I repeated myself. No, the last one is not BCA, is ABC, yeah. So the last one is measure of angle ABC. Okay. So this is what we're looking for. We're looking for the measure of angle BAC. The measure of angle BCA is 45. The measure of angle ABC is 35. That adds up to 180 degrees. Okay, and then let's combine these two. Measure of angle BAC plus, if you add these two together, you get 80 degrees equals 180. And then you subtract 80 from both sides. And measure of angle BAC is what? 100 degrees. So your answer is option letter B. All right, let's take a look at problem 14. We're looking at fractions and geometry together. It reads, Antoine drew the circle graph below describing his time spent at school in one day. His teacher said that the number of hours listed were correct, but that the central angle measures for the sectors were not correct. So those angles aren't provided. What should the central angle measure for the core subject sector be? Okay, what should that angle be? So we are looking for the measure of this angle right here, question mark. Okay, now what is a fraction? A fraction is simply part of a whole. Okay, so fraction is basically part divided by the whole thing. All right, so in this situation, the core subject's time or hours is a fraction of the whole school day, which is 1. Okay, so let's represent that with an equation. Okay, so fraction of core subject is equal to what? Is basically equal to the time on the for the core subjects over the entire time. Okay, so fraction of core subjects, how much time was spent for core subjects? 4 hours. And then how many hours for the whole school day? You just add all the times, right? So 4 plus 3 plus 1 plus 1. Okay, so that gives us 4 over 9. 4 over 9 represents the fraction of hours of the whole school day that was spent on core subjects. Now we are to represent that using degrees. Okay, Now, what fraction of a full circle is 4/9? Well, we need to know what a full circle is first, and then we'll take 4/9 off a full circle. Okay? Angular measures is what we're focusing on here. So let's write down a real quick remark. Since a full circle, a full circle, it measures how many degrees? 360 degrees, right? The core subjects is going to be 4/9 of the entire full circle. So 4/9 of 360 degrees. All right, it's like you're taking a slice of the pie. So let's see what this comes out to. 9 goes into itself once, and 9 goes into 360 40 times. 4 times 40 is 160 degrees. So this is a degree right here that represents the number of the degree of the hours spent for course subjects. 160 degrees. Answer is option letter H. All right, let's take a look at problem 15, the last one in this review installment. That reads, this month, Cami sold 70 figurines in 2 sizes. The large figurines sold for $12 each, and the small figurines sold for $8 each. The amount of money he received from the sales of large figurines was equal to the amount of money he received from the sales of the small figurines. How many large figurines did Cami sell this month? Okay, so to get started, I just want to go over a formula with you real quick concerning calculating amount. So formula, the total amount, it could be for the small or the large figurines, it doesn't really matter, is basically the unit price multiplied by quantity. Okay? Now you might ask yourself, why am I writing this equation down? We have a mention of unit price twice in this problem. $12 each, that's the unit price for the large figurines, and $8 each, that's the unit price for the small figurines, okay? So you want to keep that in mind. Now let's declare our variables. Even though we're just looking for large figurines, we need to declare the other unknown, which is small figurines, the number of small figurines sold. Okay, so let S equal the number of small figurines sold, and how about we let L be equal to the number of what? Of large figurines sold. Okay, now we're going to set up a system of equations. We're going to set up a quantity equation and a sales amount equation. Then we're going to solve our system of equations. Okay, so let's start off with our quantity equation. So our quantity equation is given by the number of small figurines sold plus the number of large figurines sold is equal to what? The problem tells us that Cami sold 70 figurines. Okay, so number of small figurines sold plus number of large figurines sold add up to 70. That is your first equation, your quantity equation. Second one is your sales amount equation. All right, so this one we're going to implement the use of this formula that we talked about right here. So for the small figurines, the unit price was $8, and how many were sold? S were sold. So the total amount of small figurines is given by 8S. So that's the total amount of small figurines sold. Remember, unit price times quantity, 8 times S. And we're told that it is equal to the amount for the large figurines sold. So how many large figurines were sold? The quantity I'm sorry, what's the unit price for the large figurines? It's $12, right? And then how many large figurines were sold, L? So there you have it. So we have our system of equations. We have the quantity equations and the amount equations on the bottom. There are different ways you can solve this equation. You can use substitution. I'm going to use elimination here. That's my favorite method. So I want to eliminate the variable that I am not looking for. The problem asks us to find large figurines, so we're going to eliminate the s's. Okay? Now, I want to make these s's opposites of each other, so when I combine these two equations, the s's cancel out. So what is the opposite of 8s? The opposite of 8s is negative 8s. So since this has a coefficient of 1, I can simply multiply this entire equation by negative 8 so that the s's become opposites. Alright? So if I do that, I'm going to have negative 8s plus, oh sorry, you have to distribute the minus to every single term, so you have minus 8l equals 8 times 7 is 8 times 70 is 560, and don't forget the negative, negative 560. And then here we have 8s equals 12l. Alright, so you just simply combine these two equations, and what results? If we combine these two equations, we have the s's cancel out as we desired, so we have negative 8l is equal to negative 560 plus 12l. Okay, so remember the goal is to get L isolated. To accomplish that, we'll subtract 12L from both sides. And then we have negative 20L. Let me draw my line so that you don't get confused. Combine it downwards again. Negative 20L is equal to negative 560. And then to finish this off, divide both sides by negative 20. And let's see, we have, this cancels out, L equals, and then when you do that in your calculator, negative 560 over negative 20, you end up with 28. Your answer is option letter B. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful to you, do give us a thumbs up. We'll appreciate the positive feedback. Don't forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions about this tutorial or any math concepts on the upcoming ACT test, just ask your question in the comments section below, and we'll be glad to support you as soon as possible. More clips can be found on mathcodeserve.com. Thanks again for watching, and have a wonderful day.